Hey, what's up, guys? Chung here. So this time, let's take a look at another lead code problem 1057 camper spikes. Very interesting problem. I'm gonna give my own vote here. So there's a campers represented as a 2D grid, and on each of the coordinates here, there there are like some bikes and some workers. Each of them will be represented as a coordinates x and y, right? And then you need to assign the workers, each worker with a bike. And the way you're assigning it is you have to assign basically you have to assign the you need to choose every time you need to choose a pair, right? A worker and a bike, worker and a bike whose distance, the distance is the Manhattan distance, which basically the absolute value between the x coordinates plus the absolute value of the y coordinates. So every time you need to do a sorting, and you need to choose the shortest distance for all the unsigned workers and bikes, right? Basically, that's what it asks you to do. For example, here, right? And we have two workers and two bikes, right? So at the very beginning, right? See, uh, the distance between workers 0 and bike 0 is 1 plus 2 is 3, right? Is 3. And the workers between and the distance between the worker and the bike 1 is 3 plus 3 is 6, right? And how about worker 1? The worker 1, the distance between worker 1 and bike 0 is 2, right? And then the distance between worker 1 and bike 1 is 3. So So in this case, so the first assignment will be between the bike 0 and 1, right? Because 2 is the smallest distance among all the distance at this moment, right? Basically, for workers 1 will be assigning bike 0. So the return result will be the indexes of each worker, the bike index of each worker it will be assigned. So the first one will assign the worker one with spike 0, that's a 0, and the second one will be we assign the worker 0 with spike 1, right? So basically that's this problem, right? And and if there are like more than one ways you can if there's a tie between the distance, we also we sort by the worker first and then the bike second, right? The index of worker and the bike. So okay, so that's the description of the problem, right? So I think it's obvious that in order to get to for each time in order to get the smallest, the shortest Manhattan distance, we have to calculate. Basically, we need to maintain the distance uh, for each worker to all the bikes, right? And then what? And then when we once we have the distance and when we do the assignment, we will be using a priority queue, right? So basically, we're using a priority queue to maintain how can we which I mean among all the workers and the smallest distance, the smallest bikes for that workers, which one we need to be performed first, right? Because we need to pick the shortest Manhattan distance for all the workers, right? And then we will be assigned that worker first, and then the second, and so on and so forth until we assign all the other workers to a bike with a bike, right? So okay, let's try to code this thing, right? So let's see. First thing we need to have a uh, distance array, right, to store all the distances for the workers and the bikes, right? So we do I x workers and xy, right? Uh, in enumerate enumerate workers, right? And then we'll do so for each of the workers, we'll be creating a new array to store the all the distances for the current workers, right? So we'll be having like bike, right? Distance. It's gonna be a array, right? So for J, it's gonna be a X bikes, right? And Y bikes. Yeah, here's I think Y worker in enumerate bikes, right? So what do we do here? So for each of them, we do a bike dot distance and dot append, right? Basically, we add all the distances for the current worker to this bike distance, right? Gonna be what? So that's gonna be a tuple, right? Since we first will be sorting by the distance, but if there's a tie between distance, we'll sort the index of worker and bike. That's why we need to have a tuple here. And the first one will be the Manhattan distance, right? It's gonna be x uh, workers minus x bikes plus the absolute value of y workers minus y bikes, right? And then that's the first uh, element. The second one will be the workers index, and if this one is the same, we sort by the bikes index, right? So then at this moment, oh sorry, so in the end we will be adding a distance dot append this thing to a bike distance, right? Basically here this is like the list of each worker, each worker's distance to all the bikes, right? Okay. Oh, sorry. Before we append this thing to the to distance, well, we need to sort this thing, right? Because the reason we need to sort it is the among all for okay. So for the specific workers, the s- we always try to get the shortest, the closest bike for this worker, right? That's why we sort it, and it was sorted by no, we can sort it reverse, or we can just sort it do a like regular sort, and then when we get when we get the try to get that the first element, we can do a pop zero, right? I think so, yeah. Or we can sort it in the reverse order and we just do a regular pop. Uh, I will do you know what? I'll do a sort here. So remember, so now the first element is this closest bike, right? For this current for this worker, right? Now like we said, we need to have a queue, priority queue, right? To store to maintain, right? To maintain the uh which worker we need to assign a bike next, right? So at the beginning, right? Since okay, so now we have a distance, right? The length of the distance will be the size of workers, right? Basically, this thing stores each worker's bike's distance sorted from the closest to the farthest, right? So now we just need to get for each workers, basically we need to get all the workers shortest, I mean closest bike for that worker, right? So how do we do that? So and then we put it into a priority queue. How do we do this? We do for each of the workers we do for distance in distance, right? For each of the distance, we will be doing a distance dot pop, right? Pop 0 basically, right? Since we are uh, yes. The reason the reason we do a pop here is because uh, so once we pop find get the current this small shortest bike for this workers, we'll be removing it from the distance so that later on when we need to find the second one, we can just keep doing the pop, right? Or we can maintain an index, but that will be for each of the worker, which will be too much of a hassle. So basically, we just every time we do a pop, and this priority queue, right? It will basically it will save, it will be maintaining for each of the workers, right? The current shortest bike for that worker, right? And the length of the priority queue will always be the unassigned worker's length, right? Because, so at this moment, the length will be the length of the priority queue will be the same length of the workers, right? So and then we just need to sort it basically. We can either sort it, we just do a heap heap queue here to heap queue, yeah, heapify, right? There's a function called heapify, and we just do a priority queue. It's simply just sort it, right? We can either sort this thing or we can just use like a heap to maintain to make sure the smallest one is always on the top, right? Okay, so once we have that, and then so we need to assign, right? So now we need to assign this thing. Let's do a none. Uh, the length will be the workers, uh, right? The length will be the workers' length. That's what we okay, so we need to keep doing it until we assign all the workers, right, with a bike, right? So how do we while uh assigned bike? Okay, so we're gonna define a bike assigned bike set because once we assign a bike, once we assign a bike for this worker, and that bike may also be appear in some other workers, right? So in that case, we need to keep like a set of variables to track what are the bikes we had been assigned, and then if it's already been assigned, then we just move it to the next bike for the worker, right? So and then we just do this. Assigned bike is less than length of the workers, right? So that's our stop condition basically. If each worker has assigned with a bike, and we just stop, right? And then what do we do here, right? So that's going to be the distance, right? So every time, right, we pop this like this queue basically. That will basically every time we're trying to get the smallest value for this from this priority queue, right? Uh, worker bike, right? And then equals to what? Equals to the heap queue dot heap pop, right? Heap pop, right? And then the priority queue, right? The distance here is not it's not useful. We just we can use it like this this to for that. But I'm just doing a distance to make it clear. Okay, so every time, right? Every time when we see a bike here, right? We will see a bike, and look, remember, we're doing a heap a pop here, right? So each time when we pop a thing, we know that we're trying to assign a bike for this worker, right? Because remember, this is a tuple, right? And first we check, right? First we check if the bike has not been assigned before, right? That's the happy path. If the bike is not in assigned bike set, right? What do? We simply uh, set the answer, right? So the answer will be the worker and the bike, right? And then next we just simply add this bike to the assigned bike set, right? Bike. Okay, cool. That's the happy part. So the else is a little bit tricky here. Okay, let's take a look. Let's see if a bike has been assigned before, right? So what does that mean? It means I'll try to draw something. Let's say there's a worker here, worker one, right? And there's like a worker two and worker three here. Let's say this is our priority queue, right? And in the priority queue, let's say we have these three tuples here, and the first one is a priority queue, is the workers one. The distance, let's say the distance is like let's both of distance two and worker one and the uh, bike one, right? How about two? Let's say in the priority queue, it's possible, right? We have another thing. We have a, let's say the worker one, worker two, they're the closest bike for worker one, worker two are both bike one. So then we'll be having distance two, worker two is bike one, right? We don't care about this like worker three because the worker three will be have like a higher higher like distance, which will be at the later at the which won't be popped by this priority queue, right? So let's assuming we have this thing, right? When we do a pop, right? When we do a pop, we'll be pop the first one because with the same with the tie here, we will sort by the workers first, right? So in this case, the worker one this element will be popped, right? And then we just assign this bike one to the worker one, right? And then we add this bike use bike to this assigned bike. Now this is done, right? Now the second time when we try to do a pop, right? Uh, the worker to the set this one will be popped, right? And when we pop this one, we see okay, now we're trying to assign bike one to worker two, right? But then we see we can't, right? Because bike one has already been assigned. Then what do, right? Think about it. So if a bike has already been assigned, what do we do? In in that case, right, we need to find the next closest bike for worker 2, right? Because since bike 1 is not available, then we have to find the next closest bike for worker 2. How? Right? Remember, we for each workers, we sort all the bike's distance from smallest from shortest to the farthest, right? So in this case, I'm gonna do a like two-step here. Next shortest bike, right? Equals to what? We do a basically we'll get the next candidate from this distance, right? Just like what we initialize our priority queue here, right? We do this thing again, right? We do but in this case we know the bike the workers here, right? Distance, the worker is the current worker, right? But then we need the next bike. We do another pop 0, right? And that since this one the first best candidate is not available, and then we have to go to the second best candidates, right? Which is the top the first one on the left on this array on the list of the in this distance, right? Then we do what? Now we're adding this thing back to this heap queue, right? We do a heap queue dot heap push, right? Push this into heap queue priority queue dot next shortest bike, right? Then because the next one may not be the next available the because the best next shortest bike for the current worker may not be our next round pop the next round candidates, right? That's why we need once every time when we have a new candidate, we need to do a heap push. We 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 ask the heap queue try to sort this thing for us so that the next time we'll have the next available candidates, right? And then in the end, we just return the answer. I think it should work. Let's see. All right, cool. Let's try to submit it. Cool, it works. And so okay, so let's recap. Okay, so first we we stores we stores all the for each workers we stores all the distance for that workers, all the bike distance for that workers, and we sort the distance either way. Basically, we sort all the bikes distance for that worker, and then we are using a priority queue to uh, to help us decide who is the next worker that needs to be assigned with a bike, right? And then we also keep maintaining assigned bikes here because two workers may two workers may both have the same bike as the next as the shortest bike, right? So if bike has not been assigned before, then that's a happy path. We just simply assign this answer with current workers index with the current bike index, and then we add this bike to the set. If not, here's the part we need to take more extra uh, attention here. Then if the bike has already been assigned, which means, okay, the current bike is not available for the current workers, then we need to go to find its next shortest bike for the current worker, and then we push this result to the queue, the heap queue again, and then and so the next time it will help us find it, decide which worker is the next one to assign, and how can we make sure each of the worker will be assigned with a bike, right? Remember, so at the beginning, the priority queue, each element represents the a worker, right? Basically, so in the priority queue, there won't be any duplicate workers element. So that's the key things we need to remember here, right? Because when we create this distance, uh, for each worker, it will have its own element in the distance. So that's why from the beginning, the priority queue, each element it's unique for that worker. That's why. And when we do a heap push, and we also push the element for the same workers, right? So which means every time when we assign a workers with the current with the an element from the heap, we're always assigning that a new worker, right? And since we know uh, when we when this heap queue is empty, right? Basically, that's when this like assigned bike is the same as the workers, right? Then we know all the workers has had already been signed with a bike. Hmm. Okay, I think that's the best I can explain so far for this problem. Yeah, and yeah, I hope you guys enjoyed, like it, not even not enjoyed, but don't hate it. Pardon my explanation sometimes. Yeah, I'll keep improving, and yeah, thank you so much for watching the videos, and I'll be seeing you guys soon. Bye bye.